Good afternoon, everybody. Yeah, I would like to welcome you to my presentation about secure copy protection for mobile apps, in particular about Android. Maybe first a short introduction. Oh, I have to stand here, sorry. Maybe a short introduction about myself. As I was introduced already, I'm from the Technical University of Munich, employed there as a research teaching associate, mainly teaching, working on my PhD about this topic. Yeah, I have been a guest speaker at various universities internationally already. Originally, my major was information technology, and yeah, my current research area is Android security. A little bit about my supervisors as well. So Professor Baumgarten, also from the Technical University of Munich, is my main supervisor, and Tom likes us to have an additional mentor. So I asked Professor Song from the University of Missouri, Kansas City, USA, to be my mentor in this case. In addition, I would like to thank all the students who contributed to this project. So nowadays it's really a long list, and this list is still not completed. So thinking about the status of my dissertation, it's maybe 80%, so the last 20% are running now the last year, and so the list is not completed yet. A little bit about the content. I thought I will introduce you to the topic first before actually proposing my ideas. Before coming to the actual findings right now, and actually what we are doing, or what I am doing right now, ongoing research, before coming or summarizing a temporary result from the current status. And also I would like to cover related work, because there's really lots of it. I started to look for a dissertation topic actually a few years ago, back in 2012. Had the pleasure to choose it myself, so my boss just said, Nils, you can pick any topic you want, and well, while this might be fortunate, it's sometimes really difficult, and so I looked around, what can I do, and for some reason I came together with a company working with secure elements, and they had some interesting projects for Android, and so I had this in mind when I focused on Android security in 2013 while looking at the reengineering possibilities for Android. Some other researchers did this long ago already, around 2010, checking the license verification library for issues, and well, in this case it's really very easy, so you basically essentially just have to change one line, decompile it, change one line. So for instance, change the switch statement there, or change the value there, so it's really just one line change to get a valid license here. Thinking a little bit about how this actually works, I'm not sure if everyone is familiar with the library, how this license verification actually works. So for instance, we have just one sample app, for instance, and here we have actually the Google Play app, which is connected by this binder, so basically some sort of message servers, and each developer is integrating some example code, which is actually already the issue, because every developer is integrating the same example code. Well, they are supposed to change it, but we found out not many people care about it and don't change it. So we have basically all the time the same example code here with very few modifications, which makes it really easy for our attack. From this market app on this side, the messages and so on are signed, but well, this is only locally checked. So and if we think about root rights, I will cover this later in detail, we can assume here's an issue already. Well, why should we actually care about this? Copyright protection and obfuscation techniques and so on. Developers, of course, face the issue that they lose revenue, you lose money here. But what might be even worse is that others earn the money with these applications maybe. They just repackage it, they change some IDs maybe, and distribute it again to the market, or other markets, Russian markets whatsoever, or Canadian markets. And another thing is some sort of forums, various forums, so illegal markets might have infected applications even. On the other hand, all these techniques that we discovered might be used for other technologies. So for instance, thinking about in-app billing, it's pretty much the same, and you can circumvent it in the same or very similar way. And all these methods we found out may be applied there too. So we took a look at this LVL in more detail, and we found out, well, or I had the idea, is there a possibility for a man-in-the-middle attack? And we came out with this idea, well, this exposed framework is out there to basically allow developers or users to modify applications dynamically on the fly. And we thought, well, that might be great. So we will just intercept some function calls and exchange the parameters. And of course, this did not work with the keys. So we had basically had to fake the public and private keys as well and insert it in the appropriate methods so that on the client side, all the applications think, hey, we have a valid license, while the Google service, of course, notice, no, this license is not valid, but the customer or this attacker doesn't care about it. The application works in this case. We notified Google about this issue. Unfortunately, they classified it as low security since it only applies to rooted devices. Okay. If we look at the rooted devices, we can fairly assume there are lots of root exploits out there till now, and especially 2014, if we look at the devices, these are sources from Android vulnerabilities.org, which devices are secure or not secure. I guess it's fairly to assume that there are, well, no secure devices at all, or very few. Thinking about 2015, we heard about this already, the stage fright. There's another root exploit, one class to... Yeah, but it allows access to APK files and private files and so on and so on. Or basically this one. Yeah, as I mentioned already, I guess it's fair to assume that we can access all this data, the private files, by applications and so on, the APK file. So my research question here, or my initial research question, basically was how can we achieve that an app can only be executed on a valid device? And valid device, of course, is a general word, so let's say according to our license. In addition, there's a sub-question, so of course, is there any solution for securing data, communication, and so on? Well, yes, there are lots of solutions here. So on the one hand, we have these software modifications that were mentioned already, so SE Android by the NSA, for instance, or Fraunhofer worked on it as well with TrustDroid. We have ARM's Trust Zone on the hardware side, or the even improved version by Samsung Trustronic for Knox is the newest one from them. And we have these plug-in devices from Giesecke and Devrient, for instance, or Swissbit, basically secure elements that may be used. A short introduction about these items. If we think about Trustronic for Knox, it's basically a trusted execution environment system. So we have on this side basically our usual apps, and on the other hand, we have this trusted environment where our applications are running that should be safe. So think about a banking app maybe where you want to enter a PIN or a user credentials whatsoever. You can do this on this system in a very secure way because it has dedicated access to the hardware, to the touchscreen, to the screen. So whatever Trojan is running here cannot access it on this side. On the other hand, we have the secure elements. So basically you have some sort of app in the current case. You may use the interface of the provider of the company. So for instance, Swissbit or Giesecke and Devrient and so on, they are providing some frameworks here. Or what you can do, or what we actually do, we communicate with the with the secure element, with the SD card directly, and so there are actually two ways to access it, and you can assume here are running some sort of apps in a secure world, similar to this one, and for instance, you may calculate some encryption keys here or whatsoever, sign some data and send it back to the application for further processing. Well, I mentioned, well actually I'm mentioning now, we chose the middle way, so secure elements, and actually due to cooperations in the past, so I had all the dev kits there and so on, I chose their product. Since it's available to many devices. So here you will need special hardware. This is only software, so there's probably a root exploit at some point again. And this is something in the middle. Now we might say, well, think about the Nexus 5 and so on. How can you actually use a micro SD card? Well, yeah, I had this issue. And I thought, well, let's just use a micro SD, micro USB adapter. So one new requirement is basically to have this USB on the go. On the other hand, some Android versions have issues with buffered access. So we were required to find a workaround for this O-direct issue, basically to send a comment to the SD card because it's a second interface besides the ASSD interface. So these cards use a special file so that you can communicate with the secure element. And yeah, you are basically sending a comment to this card and receive a reply. And if buffered access is enabled, then of course it doesn't work. So this is a real Android issue, and there's actually a thread for it. And well, after some time, we figured out there's another issue. Just mounting the SD card is already a problem because you will need root writes here as well. And our goal was to avoid root writes at all costs if possible. So we developed actually this library for it, which is accessing the raw device through this micro USB adapter, the raw file system, by just asking Android or the user for the USB permission. So do you want to allow the application to access this device? And with this, we actually avoid the routing issue because we can just access it. And of course, since we interpret our file system ourselves, we can just avoid this issue as well and can communicate with the secure element directly. Which brings me to the actual proposal. After we solved all these issues, we thought about, okay, we have this dongle in the desktop world, and can we actually not apply this on the Android side as well? So we're thinking about ideas of binding apps and secure elements together. And we came up with this solution or idea where we have maybe some sort of license server, where we have our secure element, MSC, and where we have our Android side, our smartphone, our application with its data and so on. And each application basically has, we called it MSC proxy, because this is a slave element. It has to be polled all the way if it wants something. Same way from the app if it wants something. So the idea could be, for instance, that we store here some license data which may be updated from the server side and which can respond. For instance, think about I'm flying to the US once in a while, and of course I want to use my application and need a temporary license, something like that. So we can generate this secure license from on this side and basically change it after the flight later on with an update. Of course, there are lots of further ideas. So thinking about device and user identification, which is probably essential for copyright protection. So we investigated the possibilities on Android, how to basically identify users, how to identify devices. So this is just one example. So for instance, using the dark frames. I'm not sure if you are familiar with this. You have the camera, and that's actually not, maybe I can increase this. Yeah, it works. So these are different camera images, basically when there's no light. So you notice already there's a difference here due to the sensors being different, whatever reasons, manufacturing reasons maybe. So we can distinct between different devices here already by this attribute. Of course, there are many more, so Bluetooth hardware, what packages are installed maybe, of course, all the wireless networks that are around and so on. there are actually additional ideas, so some of them are actually proposed by others already, and of course we thought, well, we can just actually improve it with secure elements. So for instance, thinking about the content protection. Usual files, we can encrypt them and deliver the key basically on requirement. So the secure element can deliver the key later on. Or we can, the same applies to strings, so we can decrypt and hide all these messages in our application or URL protection and so on. On the other hand, we can also obfuscate the execution using reflections. Of course, it makes everything slow and so on, but it's a pretty good way to avoid static analysis, so thinking about reengineering. One really unfortunate thing is these secure elements are very, very slow. So we have 10 kilohertz CPU here, so you can imagine doing huge calculations or processing huge amounts of data. It's not really, pardon, it's not really possible. Thinking about the actual size and response time, so we have, for instance, from an application to a secure element, it's processing about 250 bytes per request, and this takes about 200 milliseconds. So if we sum this up to these amounts of data, we have already for 1 kilobyte 2.4 seconds, something like that. And if you now imagine we have some applications running there with which are exchanging data, which are requesting data from the server and so on, we have to spend lots of time here already for different tasks, which of course affects our way how we can use this kind of protection. So to sum this up already a little bit, security benefit for sure. So every layer or additional layer is another layer of security. Nevertheless, there are lots of improvement ideas. So for instance, a native version of the LVL, since it's simply more secure. Cannot be re-engineered that easily. Or trusted execution environment, support all our ideas in the trusted execution environment in the secure world. Or maybe reinvent Google Play. I will discuss this in more detail shortly. So the first thing is native code. We assume it's more secure because it's simply not that easy to re-engineer it. Nevertheless, of course, Google dislikes this. They recommend to use Java instead of C, since it increases the app complexity. Nevertheless, we think it's more secure, especially for license for security-related topics, to use native code here. If we look at Android 5.x, we thought a little bit, maybe it's now secure. Maybe they use native code here now, and maybe they improved a lot here. Unfortunately, that's not really the case. So if we look at the way how applications are compiled on your versions, we still have here the L file and so on, which is executed later on. But if we look in this out file which is generated, we still have the DEX file with the easy re-engineer-able code in there. So it's really easy to still get the code and so on. So another idea was, that's actually ongoing research right now, reinvent Google Play. So instead of delivering these APK files and so on, why not deliver to the device native code only? So, and maybe add some sort of security here as well. So for instance, collecting some user data, some user details, and actually use it during the compilation. So that this whole app is only runnable on a device which has the same user, the same attributes, device attributes. Another thing is a native LVL. So a lot of people are using here this example code, and you can on the fly modify it and crack it and so on. You have all these call names actually, which everybody knows and so on. Why not put everything in a native library which communicates with the Google servers directly, so you get rid of a lot of information, because all these informations which are still available here are actually the issue. Well, concluding this right now, we have to assume all these solutions, LVL by Google, for instance, or even Amazon is even easier to crack. Amazon DRM, pardon me, is not sufficient for copyright protection right now. So as I mentioned already, every additional obfuscation or every additional layer helps against reengineering here already. Of course, this is always the question, does this affect the performance of the application? Maybe, well, that's not my focus right now, so I'm more working on the security side. And I have to assume secure elements provide additional security here. Nevertheless, I have the issue right now, I cannot process that much data. I'm limited to a few kilobytes here. Which actually brings me to future work. So it would be really interesting to have a performance secure element which is able to process lots of data, decrypt files on the fly maybe, or there are even additional ideas that might be thought of, thinking about a stream of an application maybe. So just that I click on a stream and so on and interact with it so that everything is more secure here. On the other hand, the idea might be, and I don't have the information that I would like to have about trusted execution environments here yet. So that's why I'm actually also here to see the talk next. I have the hope that trusted execution environments provides a much more performance than secure elements here, since they are using, to my knowledge, the same hardware as the host system, even they are running on a different system. And of course, there's lots of related work, so even Google recognized, well, there's one gap left, so they introduced Project Vault at the recent Google I/O, a secure element for everybody, more or less. There's not much information available right now. Nevertheless, copyright protection using smart cards, kind of secure elements, is or was discovered, was researched years ago already, for instance, by Thomas Aura. I believe he's from Microsoft, and his statements are quite interesting and still true. So, for instance, copyright protection is always, to some extent, security by obscurity, and also all these methods, all these ideas always extend the time for pirated copies actually only. So there will be a pirated copy at some point, but our goal is to prevent and have more time as much as possible till that happens. A very interesting approach also was presented by Wu Zhu, I hope I pronounced his name correctly, a completely virtual machine-based protection. So you don't have Dalvik anymore and so on, and all these opcodes there, they reinvented everything. And so basically, if you are using some sort of reengineering APK tool whatsoever, you get immediately an error. And they completely exchange everything in native code and so on. So a really interesting approach. Unfortunately, due to the pre-compilation of art, I have to assume that it's not working with the newer Android versions anymore. And another slide, furthermore, all papers related to malware and so on, copyright protection are of interest to me, of course, because simply I want to hide my copyright protection methods. So they have lots of interesting techniques, for instance, recognizing emulation tools. How can we recognize that we are running in an emulator? The sensor values are probably different and all the time the same or something like that. So there are lots of ideas in these papers which I can use to hide, of course, and change my my actions when the application or the protection has a feeling that it gets analyzed by someone. And of course, all these papers about trusted execution environments are of interest to me as well. Yeah, well, I guess that's it, yeah. So, thanks very much. Any questions?
So thanks for a very interesting talk. Are there any questions?
So, yeah, you said in the beginning that one of your goals was to, counteract rooting, because if you root the device, you can circumvent LVL or whatever they're using. But looking at your library here, you're using the USB manager and related APIs to communicate with the secure element, right? So assuming the device is rooted, you can probably assume that they can change, the framework or whatever to intercept this USB communication.
Yes.
And probably, change the outcome. If you return 1, they return 0 and things like that. How do you solve this in your system?
Yes, that's a big issue. Since you always have to show the user, which is in the insecure world, if I call it this way, and we have to interact with them, of course, it's almost impossible to somehow secure it. We can only make it more difficult, we can add more layers to it, decrease the performance by this way. Well, yes, that's still a big issue. So I have the hope, the distinct hope, that trusted execution will solve this in the future.
Any other questions? Okay, then I would say let's continue with the next talk.